Good. Happy Monday. We're in week 3 of 4th quarter. So 6 weeks. Senior interims are Thursday, May 6th. Underclassmen interims are Thursday, May 13th. Please do not fall behind. You can come to my 5th period, Mr. Shamnu's 5th period, or Mr. Roman's 5th period if you need help, or Ms. Betzer's 5th period. You can come to office hours Monday and Thursday, and there will be Wednesday check-ins. It might be slightly modified for those taking the MAP R or M. So we're going to watch a video on albedo and greenhouse effect. We're going to talk more about what the albedo effect is and how it can impact the greenhouse effect. And then your homework will be to answer the question of the week. Okay, so I'm going to go ahead, and while I'm playing this video, if you can answer this question on your slides, and then we'll discuss it.
So if you don't already know, Grammarly is an online writing assistant, and it pretty much helps users become more clear and effective with their communication skills. If you're someone...
Imagine a hot summer day, and you're walking along and you have two choices. You could choose to walk over here on the dark blacktop covered road, or you could walk over here on the green grass. All right, and we're not thinking about cars here, we're just thinking about the surface. Which surface on a hot summer day would you prefer to walk on? So think about an answer to that question. Think about why you would choose that surface. And then think about the chemistry concepts behind it that we could possibly be talking about when we just come to think of what surface are we going to walk on in the summer. So think about all that before we go on.
So why is the pavement hotter than the grass? It has to do with the sun and the sun and the temperature, but also the color of the ground. The darker the ground or pavement, the more sun it absorbs and it becomes hotter. So walking on grass or even concrete that is white is going to be cooler than asphalt, black pavement. Okay. So that leads us into albedo. Albedo is the percent of solar radiation reflected back into space. So it's the ability of a surface or a material to reflect sun. So clouds actually reflect sunlight back. So our atmosphere is very important. For example, land and oceans have low albedos. Typically 10 to 14% is reflected back. So I want to underline that. So land and ocean, typically about 10 to 14% is reflected. And they tend to absorb more energy than they reflect. While snow, ice, and clouds, because of their color, because they're lighter in color, are going to have very high albedos. They reflect 70 to 90%. And they reflect more than they absorb. Okay. So this is why people panic about the ice caps melting, because they're not going to reflect as much of the sun rays back into space, and that just tends to heat up the Earth. Okay. So while we're watching this video, can you summarize what is meant by the term albedo and how it affects radiation reaching Earth's surface, so reaching our land and oceans? And then also, would you expect Greenland to have a higher albedo than its surrounding areas?
Number 2 on the 50 best jobs in America for 2021 list. Data science roles are game-changing for the ambitious.
The Earth receives energy from the sun, some of which is reflected back to space. Albedo is the fraction of this energy that is reflected. Albedo is critical for the Earth's energy balance and climate. For temperatures to stay in the same range from year to year, incoming solar energy must, on average, equal outgoing energy. Bright white clouds reflect the most sunlight and therefore have the biggest impact on Earth's albedo. These weekly maps are reflected solar radiation for the past 10 years. Lighter colors show more reflection and darker colors show less. Notice more reflected solar energy where there are persistent clouds, wind-blown dust from the Sahara Desert, smoke and pollution, and over snow and ice. One way humans impact the global energy balance is by modifying the Earth's albedo through industry and transportation, such as ship tracks and jet contrails. Agricultural burning and land use change also modify albedo. These land albedo maps show how reflective Earth's surfaces are from month to month. Bright areas with snow and ice have high albedos that can be close to 1, meaning almost all.
So this is Greenland. So notice how much snow and ice is there throughout the year.
The sun's energy is reflected back to space at these locations. Gray areas are missing data, either caused by persistent cloud cover or lack of sunlight. Notice that missing data peaks at the North Pole in December and at the South Pole in June. Deserts are brighter and more reflective in places with thick vegetation, such as rainforests. The albedo of the ocean is not shown here, but is generally low, less than 0.1 if clouds are not present. The brightness of clouds, airborne particles, land surfaces, and the ocean all contribute to the Earth's energy balance and climate. There's still a lot we don't know about how much sunlight is reflected back to space and how humans impact albedo.
Okay, so this is the percentage of sun reflected back into space. The more sunlight is reflected, the less is absorbed by the land and oceans. So it can block the radiation from reaching Earth. And that's not necessarily a bad thing. The solar radiation is what allows our plants and food to grow. Actually. So we need the solar radiation. It also keeps us warm. But we don't want to have too much. Okay. I'll bold it or not bolder. Let's change the color. Make it a little easier to see. And then if you recall Greenland, when you looked at Greenland, it was a lot of snow and ice. So Greenland has a lot of snow and ice throughout the year, and we would expect it to reflect more sunlight. So it should have a higher albedo. If it helps, think of albedo as albino, because the lighter it is, the less pigmentation, even amongst the clouds. Even like you think of the desert, it doesn't have the color that our rainforests do, so it is more likely to reflect things. Okay. So this is a positive feedback loop between the amount of ice on Earth and its average temperature. Okay, so less of the sun's radiation is reflected by ice, then the temperature increases and the ice melts, which causes more of the sun's radiation to come in, or less reflected, which increases our temperature, and the ice melts. So that's considered a positive feedback loop, even though the outcome is negative. Okay. Whereas more of the sun's radiation is reflected by ice, the Earth's temperature decreases, so more ice forms. So this is also a positive feedback loop. So even though the effects can be negative, it's because as more sunlight is reflected, the temperature decreases, more ice forms. And then here, if less is reflected, the temperature heats up and ice melts, which causes less to be reflected. Okay. So an increase in global temperature causes snow and ice to melt, which decreases the extent to which they cover the surface, which decreases Earth's albedo. Oh, I have to use the box highlighter. Okay. This decrease in albedo means more energy is absorbed, which causes further warming, which can cause more further melting. Okay. The ice albedo positive feedback loop accelerates the change in global temperature. Remember, we were talking about, global warming and the greenhouse effect. So as it affects global temperature, it's critical to understand when you're trying to predict climate change, because some places may cool down and some places may warm up, and then that may change the surface of the land. So what role would seasonality have on Earth's albedo, and how does the Earth's albedo change over the course of a year? So if you remember, typically we have more snow or ice in winter and probably more clouds during spring and fall if you think about how much it rains. Okay, this would affect the albedo and how much sun can be reflected, which would affect the temperatures on Earth. So the more climate change, then the more changes in weather patterns will affect how much can be reflected, which is your albedo. All right. So human activities that create pollution also influence the energy balance, if you remember from the video, because it can release materials into the atmosphere that can make clouds darker or make clouds themselves, like when we talk about smog. Those are all pollution particles. Eventually, so when we burn coal and other carbons, other fuels, the soot is that black stuff released from candles. It's also released from other carbon-based compounds. And when it's in the atmosphere, it's deposited back on Earth and makes the snow and ice look darker. Remember, when things are darker, they absorb more energy. Right? So that's why if it's sunny, but the temperature is low, so in the winter, a lot of our clothes are darker so that we can absorb more sunlight and stay warm. So the darker the snow and the ice are, the more radiation, the more it melts. Okay. So as the snow and ice melt, the soot embedded in the snow is left behind. It becomes more concentrated surface and it just accelerates the warming. Okay. So does anyone have a different example or remember something from the video about forest fires? So forest fires increase the albedo because the trees and plants are no longer present to absorb the sun's radiation. The soil will just absorb the heat and not reflect it. So the temperatures increase. Okay. Something else that we do is also pavement. Remember we talked in our example, you could use paving roads with darker surfaces. You know, some states they use more gray pavement instead of the black. The black obviously is easier to see at night, but if they would use more gray surfaces, it would actually reflect a little more. So you could also add in an example on asphalt or roads. Okay, so in this diagram, we see land use changes. So there was lots of trees. They took all the trees down and put in a manufacturing plant. It's giving off sulfur dioxide. There's more dust now because they took down the trees. There's carbon dioxide. If there's biomass burning, there could be soot released. And it creates this foggy haze, which we call smog. And it will partially reflect and partially absorb. And same with our clouds. So it could actually lower the amount of sun getting through, which could also be a problem if, you need that sun to grow plants. But it could also the smog can also trap more of our greenhouse gases in our atmosphere. So even though we're not getting as much sun, we can still change the temperature. So it just depends. So let's read. And I'm not sure if I can underline this one or if it's a picture too. It's a picture too. Oops.